Welcome back to Program with Akshay. And in today's video, we are going to start with our project 2, that is ALB, that is auto load balancing, okay, of EC2 instances. So in this project, we are going to start to create a new stack where we'll create a VPC, an internet gateway, EC2 instance, and auto scaling groups. Okay, so we will see how to create these stacks one by one. Okay, and like how to create an NAT gateway, how to create an application load balancer, how to add a listener. We will again add a user data, user script. We will create auto scaling groups, and we will create those EC2 instance. Okay, so we will create the minimum instances of 2 and maximum instances 3. Okay, and we will add a threshold, or we will add a, you can say, a skill request count. Like, so suppose a target request is 60. Okay, and we will add a CPU utilization or target CPU utilization. If it is more than 75, then the number of CPU instances will launch CPU instances of maximum reserve capacity as 3. Okay, so we will see this step by step in this project. Okay, so this is the architecture of our current project, where we are going to create, or we are going to import an existing VPC. We are inside this region. We are creating a public subnet. Inside the public subnet, we will create a NAT gateway. Okay, and the internet bound request, which will communicate through internet gateway protocol, and then send the request to the NAT gateway, which is in public subnet, and this will redirect to application load balancer, and this application load balancer will launch the auto scaling groups of our min and max instances of our EC2 instances. If it is an HTTP bound, we are going to send the request to the application load balancer, and this application load balancer will send the request in the EC2 to the EC2 instances to the auto scaling group, which are hosted in the private subnet. Okay, so this is very simple diagram. Okay, we have for the internet bound, we are have creating the internet gateway, and for HTTP bound, we don't have any internet gateway, that is directly communicating with the application load balancer, and those are retrieving those requests from the user data to the auto scaling group, which is hosted in the private subnet. Okay, so let's start creating our stack. Okay, so before creating our stack, you should have the Visual Studio, and inside the Visual Studio, I have already created a new folder, ALB stack project. And inside the new project, we will fire up the new terminal, and we will give a command called as CDK init app hyphen language, and in our case is TypeScript. Okay, so this will bootstrap, or this will create an application in the CDK, and this will create all the folders, okay, for the CDK, like node modules and package log.json and package.json. Okay, so we will wait for a minute to initialize our template or initialize our CDK project. After initializing, we will start to import those stacks into the lib folder. Okay, so this is the lib folder, and this is the main entry point of our lib folder. Inside this lib folder, we will try to create all the stacks. Okay, so let me pause the video. After executing this npm install, this will take a couple of minutes, and after this npm install, we are good to go, and we should able to see our stack has been, or we have, what I can say, we can see our project has been created. Okay, so our stack has been created. Okay, so this is our lib. Inside the lib folder, we have something called as ALB stack project.ts. This is the main file where we are going to create an actual stack. Okay, so before doing anything, let me import all our packages from our AWS CDK lib. We need EC2, we need ELB, okay, elastic load balancer, and we need auto scaling. Okay, so for EC2, we have something called as, in the previous project, we have already imported EC2. So import star as EC2, okay, from AWS CDK lib slash, we have something called as AWS hyphen EC2. Okay, so this is for EC2. Now similarly we need for ELB. So import star as ELB version 2, okay, from AWS again slash CDK AWS CDK lib slash AWS elastic load balancer v2. Okay, and for auto scaling, we have some similar for auto scaling. Import star as auto scaling from AWS CDK lib slash AWS hyphen auto scaling. Okay, so these are the imports packages which are required to create those tags. Okay, now the first and the foremost thing we will try to create, okay, as per diagram, we will try to create NAT gateway. Okay, so we will try to import the existing VPC. So I will create a new variable called as VPC, and we'll have that inside the EC2 instance. Okay, so we will try to attach this NAT gateway to the EC2 instance, and this EC2 instance is attached to where? To our VPC. Okay, so we have something called as VPC. Now the scope is this. Okay, give any name, like suppose VPC, and we have something called as, sorry, VPC, and we have something called as NAT gateways, G capital if I'm not wrong. BAT, it's not BAT, NAT gateways, yes, NAT gateways as one. Okay, so we are only the NAT gateway as one. Okay, one NAT gateway. Okay, and this will be hosted on the public subnet. Okay, now the next thing, we are going to create an application load balancer. Okay, so to create an application load balancer, we will try to create a variable const ALB new AELB version 2 dot application load balancer. Okay, scope is this, give any name, ALP. Okay, and inside this we will have the properties as VPC. We are going to attach to the VPC, existing VPC, and internet facing. Okay, this is internet facing as true. Okay, so we are for if you see the diagram, like for internet facing request bound, we are exposing the application load balancer to the internet gateway. Okay, so that internet gateway is communicating to the NAT gateway, and NAT gateway is trying to communicate with the application load balancer. Okay, if you see the diagram. Okay, so if it is an internet bound, it is trying to communicate with the internet gateway first, and then it is sending the request to the NAT gateway, and after sending the NAT gateway, it is trying to communicate with the application load balancer, and it is sending request to the auto scaling group. Okay, so this is the stack, okay, for application load balancer and for NAT gateway. Okay, now we need to add a listener, okay, to this application load balancer. Okay, so let's add a listener here. Okay, let me put a semicolon at the end. So const listener, which will listen at port 80. Okay, so ALB, which we have created a variable, add listener. Okay, give a name listener, correct, and inside that we will try to add the properties, port as, specify the port as 80. Okay, and we should try to open, okay, that port as true. Okay, so these are the properties for the listener. Okay, now the next thing, we are going to create EC2 instance. Okay, and inside the EC2 instance, we will try to create, or we will try to import the data for the EC2 instance. That means the user script data. In the previous project, we have created something called as user data script.sh. Okay, but whereas I will try to add the user data inside the EC2 instance. So I will show you how to add that. So const user data is equal to EC2 dot user data for Linux. Okay, and we end at now user data dot add commands. We have something called as add commands. Okay, and inside this you will try to add each and every command which we try to add in the previous project for the user data script. Okay, now first what we have to do, we have to, like, for sudo su, to assume that it is administrative privileges. So that is the first. Okay, then yum install. Okay, then yum install -y httpd and http. Okay, httpd. Okay, so this is the next command, give a comma at the end. Okay, now what we have to do, we have to restart the service, or we have to enable the service. So the command is systemctl start httpd. Okay, and then systemctl. So in case of any reboot, we have to enable the systemctl http service. Okay, so the command is systemctl enable httpd. Okay, so these are the commands which we have created for user data script. Now what we have to do, we have to print the hello world. Okay, so similarly we will try to print. So the command is echo double quotes n, and here we have something called as h1 tag. Inside this we will try to print hello world from hostname dollar hostname -f. This will be closed and this will be open. Okay, and h1 tag will be closed here /h1. Okay, and now here from where we are going to do that, we are going to do it from var greater than sign /var/ww /html/index.html. Okay, so this is the file where it is residing, this HTML file. Okay, and we are printing hello world, that is the IP address. Okay, so our users data script is ready. Okay, so we have the most of the things are ready. Now the only the pending thing is auto scaling group. Okay, auto scaling group, and we are going to add targets. Okay, so let's try to add the auto scaling group to the existing VPC. Okay, and where we are going to specify again the instance type, where we are specifying the instance class and instance size and the machine image, and we will try to attach the user data to the auto scaling group. Okay, and where we are going to specify the min capacity and the max capacity. Okay, so let's do it. So declare a variable const asg is equal to new auto scaling group dot auto scaling group. Yes, scope is this, where give a name as auto scaling. Okay, and inside this we will try to attach to a VPC, existing VPC, and now we are going to specify the instance type. Okay, instance type is where we are similarly where we are going to specify the like the instance class, it is burstable, and instance size as micro. We refer to my previous project where I have explained how to create an EC2 instance with those properties like instance type, machine image. Okay, and how to add the user data. So in this project, we have already seen how to create an instance type. So I am not explaining that again. Okay, so to attach an instance type, to where we are going to attach to our EC2 instance. So EC2 instance dot instance type of, right, this correct, and we are going to specify EC2 dot instance class. We have something called as instance class dot burstable burst table 2. Okay, that will do, and ec2 dot instance size dot micro. Okay, so this is free one from AWS. Okay, so we have created our instance type. Now we are going to create machine image. Okay, machine image as new ec2 dot amazon linux image. Okay, now we are going to specify the generation for this. So generation ec2 dot amazon linux generation dot amazon linux 2. Okay, now what we are going to do, we are going to attach user data first, which you have declared above, and min capacity, we have something called as min capacity 2 and max capacity as 3. Okay, as free. Okay, so what is this min capacity and max capacity? So this min capacity, that means if we have, suppose we have kept the threshold like CPU utilization is more than 50%, so this will launch the max capacity instance of EC2 instance as 3. Okay, that means three EC2 instances will be launched. Okay, by default once you deploy this script, the minimum number of instances will be 2 and the maximum number of instances will be 3. If you try to attach a target scaling policy to our EC2 instance, that means on Saturday Sunday we have something called as load more than 75%, that will launch an auto scaling group, that means the instances as 3. Okay, and in Monday to Friday it will roll back to the instances of 2. Okay, so this is how an scale in and scale out policy of EC2 instances work with the help of auto scaling group. Okay, now after this we are going to add targets. Okay, inside the targets we are going to specify port. Okay, port as 80, and we will specify the property as target, and we will try to attach this ASG. Okay, and we will try to add some health checks like unhealthy threshold count or healthy threshold count. Okay, so let's try to do it. So I will try to add a listener dot add targets. We have something called as add target, so this will add the target, give a name like something called as default targets. Okay, and inside this we have something property called as first port. I will specify the port as 80. Now we are going to attach targets. Okay, targets to whom? To our ASG. Okay, Now we are going to see health checks. Okay, so health checks are nothing but like we have to see the node of our EC2 instance, whether it is healthy or unhealthy. So that is why we are assigning this health checks. Okay, so this is an object, and the health check is an object, and inside this object we have to specify first is path. Okay, we have to specify path, then we have to specify unhealthy threshold count. Okay, maybe you can say specify 2. Okay, and healthy threshold count, healthy, you can specify as 5. Okay, that means the logs. Okay, and interval, we are going to specify the interval at 30 seconds interval. They are going to refresh those logs of healthy and unhealthy threshold count. Okay, so specify interval, that means duration dot seconds, specify as 30 seconds. Okay, and that's about it. So we have specified the targets. Okay, that means the target groups, that is the port 80, and the target is the auto scaling group which we have created above. So you have specified the health check, that is the path, health the threshold count, and healthy threshold count, and unhealthy threshold count, and we have specified the interval. Okay, now we are going to specify the add action, that is if we try to navigate. Okay, that means if we try to navigate, suppose slash as static. Okay, from the auto scaling group, which is trying to listen to the target port at 80, we should get some response. This is completely optional. I will try to add it. Okay, that is it is not a mandatory requirement. Okay, but if you're trying to create a CDK stack with this kind of a project, it is good to add that. Okay, so let me add. So listener dot add action, we are going to specify an action. So action is slash static. Okay, and where we are going to specify properties, priority as 5. Okay, and condition. Okay, so this is the condition. What is the condition? So condition is ELB version 2. Okay, dot listener condition dot path patterns. So we are going to specify path patterns, like similarly we have in API gateway like slash get slash post. So similarly we have something called as slash static. Okay, so that is why we are specifying path patterns. Okay, so parenthesis, and inside the parenthesis we have an array, and inside the array specify your path pattern. Okay, slash static. Okay, comma, and then we are going to specify an action. Okay, action is nothing but what we are going to send in the message body and the content type. Okay, so action is elpv2 dot listener action. We have something called as listener action dot fixed response. Okay, and inside this we are going to pass 200, and inside the object we are going to pass the content body and the message body. Okay, so content type is nothing but slash text slash html in my case, and we are going to specify message body. Okay, message body will be h1 static response from ALP. Okay, close that h1 tag, and that's about it. End it with semicolon. Okay, now we are going to see the scale on request count and the scale on CPU utilization. Okay, that is the only thing. So this part is completely optional. Okay, this is not a mandatory, but I am adding this. Okay, let me close this. I'm adding this. If you wanted to see that demo, you can do it. I will push this all the code in on the GitHub repository. Okay, you can download this code on the GitHub repository and you can try yourself. Okay, now the next thing, we are going to add the scale on request count. So scale on request, where give a minute, like requests per minute, and here we are going to specify like target request per minute, how much it should be. Okay, like 60 seconds and so on. Okay, so target request per seconds, and we are going to specify 60. Okay, so this is for the scale on request count. Now we are going to specify the scale on CPU utilization. So asg dot scale on CPU utilization, give a name, CPU utilization, and here we are going to specify like target utilization percentage. Okay, now here I will specify 75. Okay, and yeah, that's about it. I guess most of the things are been done. Now the only thing we are going to specify the load balancer DNS name. Okay, so to specify the load balancer DNS name, give new CFN output. We have something called a CFN output, which we have seen in the previous video, in the previous project. What is the CFN output is? Specify the scope as this, give a name like ALB DNS, and inside this we will specify the property value as ALB dot load balancer DNS name. Okay, and we will try to import for the CFN output. Let me try to import, and we are done with our project. Okay, so all the stacks, hopefully all the stacks should be created, and all the resources should be created. Okay, so the first thing is the NAT gateway. Okay, so we will create a NAT gateway. Then we will create an application load balancer, and we have specified the internet facing as true. That is correct, so that all the internet requests will be facing to the application load balancer, which will traverse to first to the NAT gateways. Okay, then obviously we are going to create an internet gateway, okay, which will listen to port 80. Correct. Now we have created the user data script hello world, and we have installed our httpd. Okay, now we are the main part, we have created an auto scaling group. Okay, and inside the auto scaling group we have created like instance type, machine image, and we have attached the user data, and we have specified the min capacity and the max capacity. Okay, and this part is completely optional, you can skip this part. And then sorry, this part and here we are trying to attach the auto scaling group where we have already created above, and inside this we are have attached the health check properties like the path, unhealthy thresh count, healthy thresh count, and unhealthy thresh count. Okay, and the interval. Okay, and this is the specified request per count, that how many requests can be associated with those EC2 instance with the help of the target scaling group. And the CPU utilization, that like if the CPU utilization is more than 75%, then how many instances will get launched. Okay, and here we are like producing an output, and we are attaching the load balancer DSN name to the ALB which we already created above. Okay, so that is all about it. Okay, and hopefully this should be deploy this should deploy our stack. So to deploy our stack, the first command, we are going to bootstrap the project first. Okay, once the bootstrap is done, this will create a CDK out folder. Again, I have explained all my all this basics, like what is CDK bootstrap, what is this CDK output, in my previous section videos, so you can refer my previous section videos. I will provide a link in the description. Okay, so this is the bootstrap is done. Now we are going to synthesize. If there are no error, okay, then, and if there are no syntax error, then we should able to synthesize our project. And once the we are able to synthesize our project, we can deploy our project, and we can browse our project with the help of an DNS name. Now let's try to deploy CDK deploy. So this will deploy the stack in my region. So my region is AP South 1. Okay, and let's wait for a minute here, and once our deployment is done, we should see our stack. So our stack has been created and it is deployed, and it took almost a lot of time to deploy this stack. Let's copy this DNS and let's try to paste it here, and hopefully we should see our output. Yes, we can see our output, hello world. And let's, if you refresh this IP, which will change. If you see, correct, that means our load balancing application load balancing is working fine. Yeah, now let's try to navigate to our console, and let's see our EC2 instances, and we should see our, yeah, two dedicated instances are running. Yes, so these are the two EC2 instances which is being created. Now let's try to go to our security group. Now if you see here, there is no public IP address. Okay, it is a private IPv4 address. Why? Because this is being hosted on, you can say, this is being hosted on private subnet. Okay, now if you go here, let me go to instances. Let me go to the instances, and let me try to go to EC2 instance, and let me try to go to the security group, and we should see our security group being created. Okay, this is the security group is being created. okay, which has IAM role and which should have an inbound rule as 80, correct? 80 load balancer to the target description. That is perfectly fine, okay, and the outbound rule is we have allowing all the destination, okay. And now we should see our elastic IP also. So we are creating an elastic IP with the stack of the public subnet, okay. And we should see our load balancer and the target groups. So we have created the load balancer. This is our DNS name for the load balancer, okay, correct. This is being created right now, okay. And we are in the two availability zones, okay. These are the two availability zones, okay. And these are the details for that load balancer, okay. These are the availability zones in which it is hosted, okay. And if you see the listener, okay, if it is listening at the port 80, okay. And if I try to access the path as static, I should get the fixed response. So if I try to append the path as static, I should get a response from ALB as hello world. Yeah, static ALB response. Okay. So this is all about, and we should see our auto scaling groups. And this is our auto scaling group. If you see all the details as min capacity is 2, max capacity is 2. And inside this activity, okay, these are the activities. Okay, and let me show you automatic scaling. Yeah, so these are the dynamic scaling properties which we have set, like the target scaling policy. Like if the CPU utilization is more than 75, we are launching the instances. And if there are like the request count per target is more than 60, we are launching the instances, okay. So this is the auto scaling group, okay, and this is the load balancer, and the target groups are attached. These are the target groups. And if you see the targets, okay, we have the nodes as two healthy, okay. These are the nodes, that means these are the two instances are attached to our EC2 instances. So these are the target groups are attached to our EC2. We don't have any unhealthy, okay, unhealthy in nodes or unhealthy instances. And this is the load balancer, and this is the diagram, okay, where we have created the EC2 instances in the private subnet. With the help of auto scaling group, we are launching the instances. And this is the application load balancer, which is which are inside the two regions, okay, like AP South 1 and it's AP South 1B, if I'm not wrong. And yeah, load balancer, we have two subnets. If I can see availability zones, yeah, AP South 1B and AP South 1A. Okay, so this is how this architecture, or this is how the infrastructure work. Okay, so we will cover up another project in the AWS CDK, where we are going to see the event notification. So this is we have completed the previous project, okay, and this is the second project. We will be carrying on the third project, and we will be winding up our AWS CDK masterclass. So happy learning, guys, and happy new year. Stay tuned. Let me know in the comment section if you are facing any challenges, or if you are facing any issues while setting up the infrastructure. And do subscribe to the channel if you found this content very useful, and do share with your friends. Okay, happy learning, and bye bye, and happy new year. Thank you.